Hi Algebra 1 students. What we're going to look at today is some application type problems with our quadratic functions. So in these problems, we're going to be given a graph and we're going to just answer some questions, mainly about domain, range, and also things about max and mins. So the first thing we see in problem number 1, the function f of t is equal to negative 16t squared plus 64. Represents the approximate height in feet of a falling object t seconds after it has dropped from an initial height of 64 feet. So if we look at the graph that's provided, here we have the function negative 16t squared plus 64. We have our starting at 0, 64, and we know that it's ending at the point 2, 0. Notice here that we're only shown in quadrant 1 because we're starting kind of at 0, 64, we can't look at something with negative time, and we're only looking in quadrant 1 because we once again can't look at negative distance. So here I filled in some important information. The first two questions talk about practical domain and practical range. Remember that practical domain is just all the possible x values that make sense in our given scenario. And the practical range is all possible y values that make sense in our given scenario. So notice here, because we're not given the entire graph, we're only given and focusing in on quadrant 1 because once again, we can't have negative time and we can't have negative distance in this scenario. So the first question is practical domain. So all of our possible x values. So if we think about our x values, we're going left to right. So here, and then also stopping at that 0, at 2, 0. So once again, all of our possible x values is going to be when t or x is between 0 and 2. So we'd say 0 is less than or equal to t, which is less than or equal to 2. When we talk about our range, all of our y values, we think kind of bottom to top. So we look at our kind of our lowest point for the y values to our highest point for our y values. So see, we here, our y values, our lowest y values happening at 0, and our highest y value is happening at 64. So we should say that our practical range is going to be between 0 and 64. So we would say in inequality format, 0 is less than or equal to y, which is less than or equal to 64. Sometimes for me it helps to kind of put it with the highlighting so you can see the domain, which is in the green, farthest left to farthest right, and then in the yellow, the range, kind of lowest point to highest point. The next question says, determine how many seconds it takes the object to reach the ground. So think we start here at 0, 64, and we drop the object. The object hits the ground. When it hits the ground, the that y coordinate is 0. So it makes sense that here, it would take the object 2 seconds. Remember here that t is our time and y is our distance in feet. So use that as a help as well. So if we want to know how many seconds it takes, it would take us 2 seconds. According to the graph, the object falls from what height? Well, we can see that it starts at 0, 64. It also told us right in the problem that the initial height was 64 feet. So our answer should be 64 feet. Don't forget in these ones to add units. If you get stuck, it says right back in the problem what the units would be. Let's look at practice problem number 2. In practice problem number 2, it says an archer shoots an arrow. The arrow follows this path shown where x and y are measured in meters. So what I did first is I filled in the starting point, the ending point, and my max. I said that the shooter, the archer starts at 0, I said 1.5. We have a max height at 20, 1.6 I estimate it to be at, and it ends at 90, 0. So once again, we're going to look for the practical domain and range. So once again, when we talk about domain, that's all the possible x values. So x values going left to right, farthest left to farthest right. Here, once again, we're only focusing in on quadrant 1 in these types of problems so that we can talk about when the archer shoots it and then when it goes down. So we can't have a negative time and we can't have this negative distance. In this first one, we would say the practical domain would be between 0 and 90. So in inequality format, 0 is less than or equal to x, which is less than or equal to 90. The practical range, that's range is y values, so think bottom to top. So if I say the lowest point that we see to that highest point that we see, we would say that our practical range is going to be between 0 and 1.6. So in inequality format, we would say 0 is less than or equal to y, which is less than or equal to 1.6. In the next problem, looking at the graph, we can see how far away from the archer does the arrow land. So think right here on that y-axis is where the archer is. He shoots the arrow and it lands right here where it ends at 90, 0. So we would say that the arrow lands 90 with our units meters. And according to the graph, the arrow begins at what height? So that's our starting point. I think this is how tall that archer is going to be. So we would say 1.5 meters. Let's look at practice problem number 3. In practice problem number 3, it says a spectator attempts a half-court shot on a basketball court. The ball follows the path of h of x is equal to negative 16x squared plus 4x plus 4, where the height of the ball is function of the horizontal distance from the person, both measured in feet. So if we think we have a person standing at that starting point at 0, 4. They shoot the basket, and we want to see eventually, is it going to go in the hoop? So I filled in the starting point at 0, 4. The max point of the ball is at 12, 28. And then it ends at 25, 0. So we're going to see what happens with the basket. Will it go in? If we start with the same two questions that we've done, the practical domain and range. So domain is all those possible x values. So we go farthest left and farthest point right. So we can see here that our practical domain should be between 0 and 25. Putting that in inequality format, 0 is less than or equal to x, which is less than or equal to 25. The next problem, we talk about our range, our possible y values. I think we go bottom to our top, or our max to our min in our problem that we see here. So here we would say that our lowest point's at 0, when the ball hits the ground, and the highest point would be at 28. So putting that in our practical range inequality format, 0 is less than or equal to y, which is less than or equal to 28. Here, what's the maximum height of the ball? We talked about that already. The maximum height would be 28 feet. How far from the person does the ball reach its maximum height? So here, we want to figure out how far away. So that would be that x coordinate of 12 feet. Now, the all-important question. If the hoop is 25 feet from the person and it stands 10 feet tall off the ground, does the person get the ball in the hoop? So we can see from the picture that I drew that it's not going to go in, because if it went in at the point 25, 10, because think here, 25 feet from the basket and then 10 feet high, it would have to go through the point 25, 10. It's really going through at the point like 22, 10. So it just misses it. Notice here that it hits the ground at 25, 0. So we would say here, no, the ball does not go in the hoop. The point would have to be at 25, 10 for it to go in the hoop. Here we see that when it's at y coordinate of 10, it's probably about 22, 10. So no good. So the ball would not go in the hoop. We can also see from that kind of me putting the hoop in the graph, it's not going to go in. So let's try one more practice problem. We're going to skip number 4 for right now, and you're going to try number 5 on your own. So in practice problem number 5, it says a golf shot creates this parabolic curve. It's represented by the function h of x is equal to negative 0.005 x squared plus x. So if we put that into our Desmos, we would see this graph, where x is a function of the distance in meters. So here, think we start the golfer, and then the golf shot, and it goes all the way down. So I want you to try to tell me these questions. So the first one, how far did the ball travel? So we can say that C, the ball traveled 200 meters. We have our starting and we have our ending. What's that practical domain? Well, hopefully we can see, we can put our highlighting in. Our domain is our left to our right, all of those possible x values in our scenario. So our domain should be between 0 and 200. What's our range? All those y values in our scenario. So our bottom to our top. So hopefully we see here that our range is between 0 and 50. Notice that it's included, so we put the lines underneath for the inequality. At what distance was the maximum height of the ball? So the maximum height, hopefully we said, would be 100. And then what was the maximum height of the ball? We would say 50. So hopefully we got those right. And if there's any questions, we'll follow through. So notice these, so just the wording is a little bit different. At what distance was the maximum height at? So that'd be 100. And then what was the maximum height would be 50. So think you're shooting the golf ball.